Hi students, welcome back. Time to do some miscellaneous things. In this part we are gonna do the topics which are again not as important as the topics which have already been discussed, but since we are preparing it completely, we must also have look at these topics. In this part we are gonna learn about subtangent and subnormal, and we are also gonna see pole, polar and some properties of the parabola. So let's start the part and learn some miscellaneous things. So starting with the definitions of subtangent and subnormal, for before that I would like to introduce one thing more, that we have done that this is, suppose this line is a tangent, okay. So we define the length of the tangent as the length from the point on the axis where it intercepts it, okay. So in this figure, if you look at it, this is the point, so this length is known as the length of tangent, and subtangent is the projection of this on x-axis, which is clearly this thing. What do I mean by projections? Just if this is a tangent, just put its projection on x-axis or this length. So already one point is being here, so you just need to project other point perpendicularly on the x-axis or whatever the axis of the parabola is. So that way you can know the subtangent, okay. So basically there are again various ways by which we can know. So again we can know that the axis of parabola, intersection of axis of parabola with the tangent, from there what we need to do, we need to find the length. Once we find the intercept, we can find this point will be known, this point will be known, length of that, and this is, we know that slope of the tangent, okay. So in this case it is only the x-axis, okay. So otherwise we will need to check it with the angle with the axis which it makes, then we can find the cos of that angle. If say this is xi, so this is cos of xi. So definitely we can find it using that way, but since in this case its axis is x-axis only, so clearly we can see that the intercept from this equation of the tangent will be minus x1, and this point is x1, so we can say this is x1 and this is minus x1, so length will be twice of x1. Now coming to the subnormal, okay. Okay, there is again before coming to subnormal, there is again another way by which we can do, we can like slope of this is known, okay, in terms of dy by dx I am telling. So we can also know that this is y1, okay. So we can also apply tan theta. So tan theta will be y1 upon the subtangent length, okay. So length will be y1 over dy by dx, okay. So in this way you can also do again, because this theta is nothing but dy by dx of the tangent at this point at y1. So accordingly we can find it in any of the ways according to the question, okay. So coming to the normal, in the normal, this is the normal now, okay. So the equation of normal will be y minus y1, and slope will be minus 1 by reciprocal of this, that will be minus y1 by 2a into x minus x1. From here if I put x equal to y equal to 0, I will get my x will as x1 plus 2a. So when the standard equation of parabola is being used, clearly now you can find this distance, this will be twice a, which we can say is half of length of latus rectum, or this is the length of semi-latus rectum, okay. Again there are different ways, so this is, you can also find it using this thing, this angle is phi, this will be 90 minus phi, so this angle will again be phi, okay, since this whole angle is 90 degree, okay. So various ways you can find it, this is xi and this is again 90 minus. So using the length, using the known thing that this is again y1, so you can again use the tan of 90 minus this thing xi phi or xi, whatever you say, this will be equal to y1 over ng, which is the length of the normal, okay. So from here we can get the length of subnormal. Okay, so this one is for your like final results if the standard parabola is being used. Otherwise you can use the help of the angles and the coordinate known y1 x1 or whatever is given, okay, with respect to the axis. In this case axis is x-axis only, so it's easy. If the axis is something like this, so then you need to check with respect to this axis. Okay, so let's move to the next topic, pole and polar. Again a very rare topic, but again it's there, so we have to cover everything. But again it can come if the paper is something different from the previous year, because the question has appeared in the past from this part also. So let's understand pole and polar with the diagram. Okay, so first I'll read it out. Then this is the parabola. P will be the point inside or outside a parabola. Suppose a straight line is drawn to the P. Okay, if I take suppose P, and if a straight line is drawn and intersects the parabola at Q and R, this will be the case. Or and for outside you can also from here, like suppose it will be this will be the case, like from an, if I take a point outside, basically if I am saying, so I am saying that if you take any point P either inside or outside here, so Q and R will be the point, then the locus of the point of intersection of tangents to the parabola at Q and R. Okay, this is something like pair of tangents, chord of contact, same thing. It's called the polar of a given point with respect to the parabola, and the point P, this P is called the, it should be pole here, pole of the polar. Okay, so pole, point P, point is known as pole and the line is known as polar. So what I mean to say that if I am having a point, if I draw tangents from that, if the point is outside we can draw two tangents, then the chord of contact will be the polar. Okay, or if the point is lying on the tangent, on the parabola, then only one tangent will be there. So then with respect to this point, this will be a tangent, polar will be a tangent. So remember that the polar is a line with respect to the point. Okay, and pole is the point of intersection of tangents. Okay, so if this is the pole, so clearly tangents are intersecting, there is one tangent that is intersecting on this point only, so that becomes the polar. Okay, and not a difficult one. So again just we need to know the definitions about the pole and polar. We will see if the questions are there in the test paper, and in the questions we are gonna discuss in the next part. Okay, so let's move on to the next topic, properties of parabola. Again very important things, whatever we have done, all the lines, that thing. So what special properties ultimately are resulted from the parabola. So the first property which emerges is the tangent at any point on the parabola bisects the angle between the focal chord through P and the perpendicular from P on the directrix. So this is P and this is the tangent. Okay, so it says tangent at point P bisects the angle between focal chord. So focal chord is this one joining the focus, and this is the perpendicular on directrix. So this is something I'll tell you, we will relate it to the reflection property of parabola. Similarly the normal, this is the normal, it intersects, it bisects the angle between the focal chord, this is focal chord, and the line parallel to the axis through that point. So this is the line through the parallel. Okay, so we can say that if I am looking at this, so external and internal division, okay, this angle will be equal to this angle, because since this is the normal. Okay, so clearly this gives rise to the reflection property, that this is, we know that any ray falling on the parabola parallel to axis, why it passes through the focus, because the normal, this is not the normal, basically PG is the normal here, sorry. So PG is the normal, it intersects this angle and this angle. So that's why we say that along the normal, angle of reflection is equal to angle of incidence. So this is the property which is being used of the parabola, that the normal it bisects the angle parallel to the axis and the passing through the focus. That's why all the lines which you are like you must have read in the physics, parallel to the axis, they passes to the focus after the reflection from concave or convex mirror. So that is what the concept is. Okay, so let's see the next property. The portion of the tangent to the parabola cut off between the directrix and the curve subtends a right angle at the focus. Again, you need to do these properties yourself, means I am explaining it, after that you need to do it by yourself again. So if I draw it here, okay, it's better if I demonstrate it on this figure only. So it says portion of tangent, so this is the tangent, okay. So it says portion of tangent to the parabola cut off between the directrix, so this is directrix, okay, and the curve. So directrix and the curve, this is the portion, okay, we are talking about, the one in the that subtends a right angle at the focus. So if I join K to S and S to this, so this is the right angle. So very simple, we can do it. So this one, if we are do it x plus x1, so we can find the intercept of this with the directrix, and directrix we know is x equal to minus a. So if we solve it here, we can get this coordinate of this point, and focus we know is a comma 0, and this point is automatically given. So we need to find slope of this and slope of this and see that it will always be, product will be -1, which means that this is again, so we need to like do the things ourselves, and then when the questions will come, automatically you will see some properties being used directly, okay. So let's see more properties. So tangents at extremities of any focal chord intersect at right angles. Very important result. So it says if any focal chord is there, and if I intersect the tangents, okay, and that they will always be perpendicular, and again they will meet at the directrix, okay. Two things are there, right angles and directrix. So basically there is one term called director circle. If you have read that in the circles, okay, so director circle is the locus of points of intersection of tangents that are perpendicular to each other. So in this property, what we are saying, from focal chord, the tangents at the extremities, they intersect at right angles at directrix. So basically directrix is the director circle, means all the perpendicular tangents of the parabola, they are intersecting at the directrix. A very key observation which we will be using in lot of questions. Again I said tangents is one of the most important things in the parabola, and you will get lot of properties, lot of questions based on this. So again look at this, so this is directrix. So if I make from any point tangents on this, so they will always be perpendicular, okay, that is one thing. And again the chord of contact will be focal chord from the directrix. Converse is what is written here, that if there is a focal chord, so you can do it, you can verify it using T1 and T2. So if you remember the this thing, equation of parabola in terms of parametric form, so you can just put T1 and -1 by T1, solve the two equations, x and y, you will get the solution as x equal to -a independent of y, okay. So you can verify that the intersection will be on the focal chord, and you can also verify the angle between the two tangents by using the slope. So slope will be 1 by t. So for any tangent, again we have done one good thing from here is that y will be equal to 1 by tx plus a t, okay. So slope of the tangent in parametric form will always be 1 by t. Okay, so that we is from the third property, and let's see the one more property. So if I erase it from here so that it becomes visible, so it says tangents and the normals at the extremities of the latest rectum of parabola constitute a square and their points of intersection being this. So what it says that if this is a parabola, tangents and normals at the extremity of the, so this is latus rectum, the double ordinate passing to the focus. So if I draw a tangent here and if I draw a tangent here, okay, and so this is not a proper parabola. If you draw it in a proper parabola, so what it says that if I draw it like this, okay, and if we join it here, so this will form a square, although it's not looking like a square right now, but you can draw it properly. Okay, I'll try to draw it using more proper way. So if this is the focus, so this is one normal and this is one normal. No, this is not the normal here. So this was the thing, and this is a point here, and this is the point here, this is the normal. Okay, so if we are making intersecting this, okay, and we are like forming a square from this, although it's not looking still, so you will get a square whose who will intersect at the minus a comma 0, which will be somewhere here on the x-axis, and 3a comma 0 will be here. So you can verify that, and once you draw the latest rectum, you know the endpoints a comma 2a, a comma minus 2a. From this you can draw the tangents, normals, find the intersection point, and see whether you are getting a square or not. Okay, so that's it from the properties of parabola. So theoretically we have completed our journey of the parabola, and I hope that everything which was covered in this part ends it well, and in the next part we are going to see some questions based on the properties and the subtangent and subnormal. So stay tuned for the next part.